Hey everyone, welcome back to the Algos learning session. So today we are again doing a mock interview, and this is again entirely unscripted, so candidate is not aware of what exactly the question is going to be. So over here, this is a little bit different mock. What I observed, the candidate has made a lot of mistakes, so you will certainly learn a lot of things from this candidate. And you can see like the candidate has come up with the approach, but still like he is struggling to code. And during the coding, what are the mistakes that he is making? You can certainly learn from this. And it was expected that we are going to have two questions, but in the first question itself, like candidate is struggling to code. So see, and you should not repeat the same mistakes. So let's jump in and see like how exactly this candidate is doing. Okay, so anyways, like okay, are you ready, or you need water or anything? Let me know. Otherwise, like we'll get started.
I'm ready from my side. I just
Hmm.
finding the copy and the pen.
Okay. Uh, So yeah, so first let me tell you like what you can expect from this interview. It is like a 45 minutes interview, okay?
Yeah,
And
sure.
then in this you can expect two problems, and we'll be solving through it. And what I exactly expect from you is like you figure out whatever the approach that you want, and then what we'll do is like we'll try to code it up as well, right?
Yeah, sure.
Okay, so let's get started. So I hope like you know about trees, right?
Yeah, sure.
So, for any kind of a tree, so the problem is, let's say you are given a tree, it's not a binary search tree, right?
Yeah.
So,
So simple binary tree or
e-
n tree.
yeah, exactly. So, what you'll have to find is the absolute difference between any node and any of its ancestor. Okay. So, what does that mean? Let me first share a doc with you. Okay. Are you able to edit it? Okay. So, this is the problem. So, for example, like let's say this is a given tree, okay? uh, so this is a given tree. 10 is a root, 10 is a root, okay? And then left is -2, and then right is -5, okay? and
Okay.
and left of 2 is again, this is 50, and then right of 2 is 3, right? And similarly
Yeah.
for 5, the left is 50 and right is 11. Now
Yeah,
let's say any node, maybe like okay 50, okay? What are the ancestor of 50? 50 ancestor is -2 and 10, right? So maximum absolute difference you will see, you will find is 52, like 50 and 2, right? The maximum absolute difference is 52, right? But for -50, the ancestor is -5, right? And 10, right? So
yeah,
absolute, yeah. So absolute difference you'll be getting with -50 and 10, right? -50
yeah, got
minus
it. My yeah, 60. My
it's 60. So the answer is 60, right? So this is what you'll have to find out for any node and any of its ancestor. What is the maximum absolute difference, right?
yeah.
Yep. So if you have any question queries, you can ask me.
Let's suppose only like there is only root, then only root. You got
Hmm.
it.
Yeah.
Let's suppose there is only root. What would we answer in that case?
So in that case, what you can return is the same value, because like there at least like absolute difference means you need at least two nodes, right?
Yeah, yeah, got it. And in this case,
Mhm.
uh, like let's suppose in this case 9 or 10.
In this case, what is your case? You have written 0.
Yeah, means only left side it has no right side. What is the answer in this case?
Yeah, in this case also like it's 9 only, because like for one the ancestor is 10, right? So it should be 9. Or like it's up to you, like when you have only one node, it's up to you like whatever you want to return. That should be fine because you don't have two
So
nodes.
because should I rate? Can I return 10? Because
Hmm.
can I return 10?
No, in this case, certainly like you have 9, right? Because it's
Okay.
perfectly valid, right?
It's a perfectly valid. Okay, got it.
Mm-hmm.
Yeah, got it.
Yeah.
Should I
Mm-hmm.
make some function kind of thing?
Mm-hmm.
Should I make a some function kind of thing?
Yeah, yeah. You'll have
Of
to
mine?
write a function which will take root as an input, and you'll have to return the maximum absolute difference. Mm. Are you writing somewhere?
Yeah. I'll start.
Okay, okay. Yeah, yeah. So.
What my approach would be, I
Mm-hmm.
would be returning two for every
Mm-hmm.
uh for every class,
Mm-hmm.
for every I would be making a pair class that consists of a minimum and a maximum value.
Okay. Mm-hmm.
Minimum in the ancestors and a maximum in the ancestors.
Okay.
Okay,
Mm-hmm.
I'll be like in the my like return function, it would be a return type of the function.
Mm-hmm.
Okay, and for every function, for every stack, I will check like uh, I'll maintain a global variable that would be storing my answer,
Okay. Mm-hmm.
and I'll be checking that my minimum. Let's suppose minus 50, 10, 10 minus 50, 10 minus 50 is
Okay.
60.
Mm-hmm.
I'll be subtracting the both with a minimum and a maximum.
Okay. Okay. Mm-hmm.
And the answer that I would get, uh, I will replace. And if the current minimum value is greater than the or less than the my current value,
Mm-hmm.
then I'll replace the minimum value and set, or in case my current maximum value that I received from the function call
Mm-hmm.
is less than that, I'll replace that.
Okay. Okay. That makes sense. So, can you tell me like what is the complexity over here?
Order of n.
Okay. And any space complexity?
Like there would be nothing for every like only two for like stacks with complexity
Mm-hmm.
order of like height of the T.
Okay. Yeah, that's perfect. Okay. Yeah. So, let's get started, and we'll write the code, right?
Yes, sure.
Okay.
I'll be writing like consist can consider of as in Java.
Yeah. Okay. So you are creating this pair that will actually you'll be passing down in every call.
Yeah. Yeah.
Hmm.
Oh, sorry. Sorry, sorry, sorry. Right. I'm taking my tree node.
Hmm.
My tree class is this.
And you are returning a pair.
Yeah.
Hmm.
Class tree node.
Uh, it should return an int, right? As for the question, like it's fine. Like somewhere, like you can return
Yeah,
an
yeah.
int.
Yeah. I'll make a different function for my calling,
Hmm? Okay,
for, for my calling purpose and different for my like that purpose.
okay, okay. Can we do a little quick because we have one more problem, right?
Yeah, sure.
Yep.
Actually,
Hmm. What are you doing over here? If let max not equal to integer dot max value, then
Yeah,
then only you are considering it.
yeah.
Otherwise, then what are you doing?
Otherwise, I'll not consider it.
But still, you are calculating answer, right?
Mm, uh, I'm calculating answer means.
Okay, this answer. So this, how actually are you calculating?
Uh, yeah, I'll calculate on the basis of this.
Okay.
I'll not calculate this. I'll calculate like
Mm-hmm.
I'm not done with this,
Okay. Okay. Mm-hmm.
and it's like some typo error.
Okay. Okay. Mm-hmm.
Yeah. Why this space is coming in between this?
Mm-hmm. Are you done?
Yeah, I'm just trying to dry run it.
Okay. Hmm.
कुर्ती इसको दिया। Hmm.
Hmm. Are you done or still doing something?
Yeah, I'm just trying one case. Yeah, means I just like.
What is that case that you're handling?
Let's suppose I haven't left dot minimum means to return that. Let's suppose uh, means minimum comes, then it will always return the minimum. So
Right.
I need to check on current root value.
Mm-hmm.
So I need to check it from the current node value.
Okay. Can we expedite it because we are left with very less time?
Yeah, just one second. T dot.
What are these too many cases?
Yeah.
Can we avoid these? Like these, I don't know. Like if whatever like you're planning, you can go ahead, but still like I don't think like if these are required.
Hmm. Yeah, these are required, but now I can. Yeah, I think now it will work.
Okay.
Hmm.
So you are initializing answer with zero, right?
Yeah,
And where actually are you updating this answer? In this is something math over here, like math dot max, right?
yeah.
Now let's say so current you are setting as root dot value, and then you're
If current
saying
equals to 0. Yeah.
yes.
This is the case when like only 10 is a root.
Mm-hmm.
Only root is there like 10. No
Mm-hmm.
left and right is there.
Okay.
So that at that case minimal answer must be 3.
Mm-hmm. Uh, so if there is a case, let's say there is something like 10, okay, and then left of 10 is like 1. In that case, can you see like if it is working?
Yeah, yeah. I think no. In that case, it would need to check for that case also. Uh, because in that case, in this case, mm, okay, that I can say that I can avoid this one, and I can just simply write here only.
Okay. So you are now directly writing answer equal to, or like, okay, you are adding some more thing.
Yeah. I think it will work.
So what is the case that you now added is if it's not equal to integer max. Okay, so there are three cases that I can see.
Yeah.
Left dot mean, right dot
Left.
mean,
Uh,
and right
and
dot max.
left dot max and right dot max. Just
I
scroll up.
okay. Scroll up. I can see. Okay. You okay? This one is the if left dot max is not equal to integer dot max value.
Yeah.
S- So meaning you are checking whether it's coming from the uh,
Yeah. Root.
like
Some like null value or not. Some like null or not.
so if there is a null, then in that case is what will happen? If let's say like entire tree is null, then in that case what you are going to return?
Returning like zero.
Okay.
Entire tree is null.
Okay. So over here like you are calling this, right?
Yeah.
And and
If answer equals to means okay, that would be null and answer. Null point one. I can check it out for this here only. Root equals to null. Return zero.
okay. And then if there is a one node, in that case you are calling this left and right, right? Yeah.
Yeah.
Okay. And then from left, what you are going to get is minimum is min value and maximum is max value, right?
Yeah.
For both, you will be getting the same, right? From the left and right because there is only one node, right?
Yeah. Yeah.
And you will be checking is these will actually will not validate because these are min and max.
Yeah.
Then answer you will be getting is math dot max answer comma current.
Yeah.
Okay. So let's say the one node
Current
that is there,
current is zero.
if this is like one node that is there is minus 10.
Okay, I need to like absolute of this. I was thinking in mind.
I think too many cases actually you are trying because this way you cannot handle the cases. There will be like a lot of cases still missing.
No, no, no. I think this is like b-
Hmm.
means this case is like I was trying to avoid like root equals to null, and else I think I have uh means checked out all the ones. Like I tried to check out.
So are you handling this again somewhere?
I have handled upward. Answer equals to zero, then it will be absolute of root value.
Okay. So first thing is you are calling it, then answer over here is okay.
Zero.
So answer over here you are saying is it will give you zero. So
Yeah.
if answer is zero, then you are returning root dot value.
Yeah.
Okay. Now, in this case, like then also I think you will get similar or what exactly you're going to get.
In which case?
If minus 10 and left of minus 10 is minus 1. Can you walk me through this, like what exactly will happen on this?
Oh, okay. Yeah.
Mm-hmm.
Like let's suppose minus and minus left of that would be minus one. So I'll call for minus 10 here. Then
Mm-hmm.
it will call for left and right. Left is left and right.
Mm-hmm.
Okay. Left left is not null,
Mm-hmm.
so it will call for its left and its right.
Mm-hmm.
Its left and rights are null, so here we'll get this. And now uh, so now updated current max and current min is like, you can say, -1.
Mm-hmm.
Here -1 would.
So time's up. So that's it, guys. Hope you enjoyed the video. See you next time. Bye bye.